So we have an f of x right over here, and it's defined piecewise. For x less than 0, f of x is x plus 1. For x is greater than or equal to 0, f of x is cosine of pi x. And we want to evaluate the definite integral from -1 to 1 of f of x dx. And you might immediately say, well, which of these versions of f of x am I going to take the antiderivative from? Because from -1 to 0, I would think about x plus 1, but then from 0 to 1, I would think about cosine pi x. And if you were thinking that, you're thinking in the right direction. And the way that we can make this a little bit more straightforward is to actually split up this definite integral. This is going to be equal to the definite integral from -1 to 0 of f of x dx plus the integral from 0 to 1 of f of x dx. Now, why was it useful for me to split it up this way? And in particular, to split the interval from -1 to 1, split into two intervals from -1 to 0 and 0 to 1. Well, I did that because x equals 0 is where we switch, where f of x switches from being x plus 1 to cosine pi x. So if you look at the interval from -1 to 0, f of x is x plus 1. So f of x here is x plus 1. And then when you go from 0 to 1, f of x is cosine pi x. So cosine of pi x. And so now we just have to evaluate each of these separately and add them together. So let's take the definite integral from -1 to 0 of x plus 1 dx. Well, let's see. The antiderivative of x plus 1 is, antiderivative of x is x squared over 2. I'm just incrementing the exponent and then dividing by that value. And then plus x. And you could view it as I'm doing the same thing. If this is x to the 0, it'll be x to the first over 1, which is just x. And I'm going to evaluate that at 0 and subtract from that, it evaluated at -1. And so this is going to be equal to, if I evaluate it at 0, let me do this in another color. If I evaluate it at 0, it's going to be 0 squared over 2, which is, well, I'll just write it, 0 squared over 2 plus 0. Well, all of that's just going to be equal to 0, minus it evaluated at -1. So minus -1 squared over 2 plus -1. So -1 squared is just 1. So it's 1/2 plus -1. 1/2 plus -1 is, or 1/2 minus 1 is -1/2. So all of that is -1/2. But then we're subtracting -1/2. 0 minus -1/2 is going to be equal to +1/2. So this is going to be equal to +1/2. So this first part right over here is +1/2. And now let's evaluate the integral from 0 to 1 of cosine pi, I don't need that first parentheses, of cosine of pi x dx. What is this equal to? Now, if we were just trying to find the antiderivative of cosine of x, it's pretty straightforward. We know that the derivative with respect to x of sine of x is equal to cosine of x. Cosine of x. But that's not what we have here. We have cosine of pi over pi x. So there is a technique here. You could call it u substitution. You could say u is equal to pi x. If you don't know how to do that, you could still try to think this through, where we could say, all right, well, maybe it involves sine of pi x somehow. So the derivative with respect to x of sine of pi x would be what? Well, we would use the chain rule. It would be the derivative of the outside function with respect to the inside, or sine of pi x with respect to pi x, which would be cosine of pi x, and then times the derivative of the inside function with respect to x, so it would be times pi. Or you could say the derivative of sine pi x is pi cosine of pi x. Now, we almost have that here, except we just need a pi. So what if we were to throw a pi right over here, but so we don't change the value, we also multiply by 1 over pi. So if you divide and multiply by the same number, you're not changing its value. 1 over pi times pi is just equal to 1. But this is useful. This is useful because we now know that pi cosine pi x is the derivative of sine pi x. So this is all going to be equal to this is equal to 1. Let me take that 1 over pi. So this is equal to 1 over pi times, now we're going to evaluate, so the antiderivative here, we just said is sine of pi x, and we're going to evaluate that at 1 and at 0. So this is going to be equal to 1 over pi, not pi. My hand is not listening to my mouth. 1 over pi times sine of pi minus sine of pi times 0, which is just 0. Well, sine of pi, that's 0. Sine of 0 is 0. So you're going to have 1 over pi times 0 minus 0. So this whole thing is just all going to be equal to 0. So this first part was 1/2. This second part right over here is equal to 0. So the whole definite integral is going to be 1/2 plus 0, which is equal to 1/2. So all of that together is equal to 1/2.